Namaste children, I am Hari Prasad, your chemistry teacher. Children, today's topic is ammonia. What is ammonia? It's a colorless gas with pungent smell and slightly alkaline taste. Children, what is the vapor density of ammonia? It's 8.5. Air vapor density 14.4. Then out of these two, which is lighter and which is heavier? Definitely air is heavier. Then how ammonia is collected? Downward displacement of what? Air. Can I collect ammonia or water? No. Ammonia is highly soluble in water. That is, 1 volume of water can dissolve 702 volumes of what? Ammonia. Now, how do we prepare ammonia in the laboratory? Before we proceed, we say that ammonia is a basic gas or it's basic in nature. Why? What is the reason for that? See, when ammonia dissolved in water, it produces ammonium hydroxide, which in turn dissociates to produce ammonium ion and hydroxyl ion. Because it produces hydroxyl ion, it is basic in nature. Right, children? So if it is basic in nature, then it has to turn moist red litmus, blue colorless phenolphthalein into what? Pink, and pink color alkaline phenolphthalein into pink, and methyl orange to what, children? Yellow. Now children, what we want to prepare ammonia in the laboratory? We want ammonium salt and an alkali. When you heat these things, you'll get ammonia. Which ammonium salt is used? We use ammonium chloride and calcium hydroxide. When we heat these two, you will get ammonia gas. How do you identify this? Take a glass rod dipped in HCl, bring it near the mouth mouth of the jar where ammonia is getting collected. Immediately you will observe dense white fumes of what? Ammonium chloride. Now the question arises. During the laboratory preparation, you always take higher ratio of calcium hydroxide when compared with ammonium chloride. What is the reason? It's very simple. Ammonium chloride is a sublimable solid, right? To overcome this problem or to counteract this, we take a higher ratio of what? Calcium hydroxide. Sir, can we take sodium hydroxide instead of calcium hydroxide? Definitely we can take. But out of these two, the most preferred one is what? Calcium hydroxide, because it is cheap. Can I use ammonium sulfate instead of ammonium chloride? Definitely you can use. Now, can I use ammonium nitrate to produce ammonia? No, boss. We cannot take ammonium nitrate because ammonium nitrate is explosive in nature. Now, once we prepare ammonia, right, during the laboratory preparation of ammonia, it has got some moisture. That moisture has to be removed. So then we require a drying agent. So which is the drying agent used in the preparation of, that is used during the laboratory preparation of ammonia? It's calcium oxide. So which is the drying agent not used during the laboratory preparation? Fused calcium chloride, concentrated sulfuric acid and P2O5. Why these three are not used as drying agent? Very simple. Ammonia with sulfuric acid will produce ammonium sulfate. Ammonia with phosphorus pentoxide will produce ammonium phosphate. Ammonia with fused calcium chloride will produce an additional product. Then ammonia won't react with calcium oxide? No. That's why that is chosen as what? Drying agent. Now, I want to manufacture ammonia in large scale. Then I have to go for what process? The next process is what? Haber's process. In Haber's process, we take nitrogen and hydrogen in 1:3 ratio, right? To get ammonia. So, to get maximum yield of ammonia, there are some favorable conditions. That is like temperature, pressure, catalyst, promoter. All these things are required. What is the temperature we have to maintain? 450 to 500, and the pressure is 200 to 900 atmosphere, and the catalyst is finely divided iron, and the promoter what we use is molybdenum. Children, in Haber's process, heat is being liberated. So this reaction is what reaction? Exothermic reaction. One more important thing is that during Haber's process, all the nitrogen and hydrogen is not converted to ammonia. There is some unreacted nitrogen and hydrogen which is associated with ammonia. How do you separate those things? That can be separated by dissolving in water. That is, we all know that ammonia is highly soluble in water, right? So this gets dissolved, right, when compared to these two. And one more method of separating ammonia from unreacted N2 and H2 is liquefaction, because ammonia can be easily liquefied when compared to nitrogen and hydrogen. Children, one simple thing actually, how do you prove that ammonia is highly soluble in water and it's basic in nature? We have an experiment. What is that experiment? You're right, fountain experiment. In fountain experiment, we take a red litmus solution which changes into blue color. Change in color from red to blue indicates that ammonia is basic in nature. Now children, coming to the chemical properties, we all know that ammonia, right, burns in the atmosphere of oxygen with a green or greenish yellow flame. Very important for the board exam. That is, the products formed during that process is nitrogen and water. When ammonia is subjected to catalytic oxidation, that is, when we do this oxidation in the presence of a platinum catalyst at a temperature of 800 degrees centigrade, instead of getting nitrogen, you will get nitric oxide with the liberation of heat. Now children, how do you confirm that this is nitric oxide? Very simple. Nitric oxide, on further oxidation, it produces NO2, whose color is, yes, reddish brown. Children, this is nothing but the first step for the preparation of what? That is, first step for the manufacture of nitric acid by what process? Ostwald's process. Now children, we have a beautiful information in this reaction. They'll ask you in the exam, why the platinum catalyst glows bright even after the heating is stopped? Your answer will be, the reaction is what? Exothermic in nature. Now children, we all know that ammonia is a very good what agent? A reducing agent. How do you prove that? Very simple. React ammonia with copper oxide. When you react ammonia with copper oxide, you will get the products copper, water and nitrogen. In this reaction, copper oxide is converted to copper by the removal of what? Oxygen. So removal of oxygen is called as what? Reduction. Who is responsible for this reduction? You're right, ammonia. So ammonia is a what agent? A reducing agent. Then how do you prove that copper oxide is converted to copper? Very simple. Copper oxide is black. Copper is brown. Change in color indicates, change in color from black to brown indicates that copper oxide is converted to copper. Now, in the same way, ammonia with PbO will give you lead, water and nitrogen. Here, how do you prove that PbO is converted to Pb? Very simple. PbO is buff yellow, not buffalo, right? And Pb is silvery gray. Change in color proves that lead oxide is converted to lead. Now children, ammonia with chlorine will give you ammonium chloride plus nitrogen. And the same ammonia with chlorine will give you HCl and NCl3. Children, in both the reaction, chlorine is oxidizing what children? Ammonia. Now children, when you will get ammonium chloride and nitrogen and when you will get HCl and NCl3, it's very simple. When ammonia is in excess when compared to chlorine, you will get dense white films, that is ammonium chloride and nitrogen. When chlorine is in excess when compared to ammonia, you will get HCl and NCl. Children, one most important thing is that, as I told you, in these two reactions, chlorine oxidizes ammonia, right? Now suppose if they ask you, name a gas other than oxygen which oxidizes ammonia, your answer will be what children? Chlorine, right children? Now coming to the most important thing is, ammonia when dissolved in water, you will get ammonium hydroxide, right? Suppose if you convert the ammonia gas to liquid, you will call it as what ammonia? Liquid ammonia. When ammonia dissolved in water, you will call it as what? Liquor ammonia. Now children, when this topic has come, I have a liquid ammonia that is ammonia in the liquid form, and liquor ammonia, that is ammonia dissolved in water. That is nothing but ammonium hydroxide. Suppose assume that I have a dry red litmus. Out of these two, which one will change the color of dry red litmus? Obviously, liquor ammonia will turn the color of dry red litmus to blue because of this reason, right? So, which is neutral to dry red litmus? Obviously, it is liquid ammonia. Now, children, what is the use of this liquor ammonia? Definitely, it is used in the identification of what? Cation. Cation, T looks like what, children? Plus. So, it is used in the identification of what? Cations. How? When I add liquor ammonia, that is ammonium hydroxide, to all the salt solutions, I will get a precipitates like this. Ferrous hydroxide, ferric hydroxide, lead hydroxide, zinc hydroxide, copper hydroxides. Each and every precipitate has got different color. That is, suppose if the precipitate color is dirty green, then that precipitate should be ferrous hydroxide and the cation present in that one is Fe2 plus. Suppose if the color of the precipitate is reddish brown, then the precipitate is ferric hydroxide and the cation present is Fe3 plus. Suppose if the color of the precipitate is chalky white, then it should be definitely lead hydroxide. The cation present in that one is Pb2 plus. Suppose if the precipitate color is gelatinous white, then the precipitate is nothing but zinc hydroxide. The cation present in that one is Zn2 plus. Then if the precipitate is pale blue, then the precipitate is copper hydroxide and the metal ion present in that one is CO2 plus. Children, the most important thing is that these three precipitates are insoluble in excess of ammonium hydroxide. Which one? FeOH twice, FeOH thrice and PbOH thrice. PbOH twice, sorry. But zinc hydroxide and copper hydroxides are soluble in excess of ammonium hydroxide and they form a complex salt of tetraamine zinc sulfate, which is colorless, and tetraamine copper sulfate, which is inky blue or deep blue. So like this, we can say that like this, we can identify the cations present in the salt solution by making use of liquor ammonia. Then finally, how do you confirm that it is ammonia? We have an important test for the board exam, that is Nessler's reagent test, which is nothing but potassium mercuric iodide K2Hg(I4). Ammonia with Nessler's reagent will produce a brown color precipitate which confirms that it is what, children? Ammonia. Okay, children? Children, this is a short revision of ammonia chapter. Hope it will be helpful for your board exam. Thank you, children. Namaste, everybody.